how do you really truly protect something you can't physically touch?
That's a great question.
It's this compelling paradox, right? Especially with the cloud, this massive invisible infrastructure.
Exactly. It's everywhere, but nowhere you can actually point to easily.
Welcome, everyone, to the Deep Dive. Today, we're plunging into, well, the fascinating and often misunderstood world of cloud security.
We're going to be focusing on the real basics, the foundational concepts, the big challenges, and also the unique responsibilities, keeping data and operations safe up there.
And our guide for this, we're building today's deep dive from an official study guide for a really respected certification, the CCSP. That's the Certified Cloud Security Professional.
Right, and what makes this source so valuable is the author, Ben Malisow. I mean, this guy has over 25 years of real hands-on experience.
Yeah, this isn't just theory, is it?
Not at all. We're talking insights from someone who's been deep in the trenches. He wrote IT security policy for DARPA, managed security for the FBI's top counter-terror network, developed security architecture for the TSA at Homeland Security. I mean, his background is seriously impressive.
Absolutely. So our mission for you today is pretty straightforward. Unpack the essential knowledge you need to, well, get your head around cloud security.
We'll cover who's responsible for what, some surprising risks maybe you haven't thought about.
And how all this stuff impacts the digital world we all live in. Think of this as your shortcut, your essential guide to keeping data safe in the cloud.
Okay, let's dive in.
So as we start this deep dive, maybe the most fundamental shift, the first thing to really internalize about cloud security is giving up control.
Physical control, that's the key.
Exactly. As the customer, you're handing over physical access to the actual devices, the hardware where your data lives.
And that, right there, introduces a massive increase in risk, a serious loss of assurance. It just fundamentally changes everything.
It really does.
And what's fascinating is how that one change just cascades. You can implement controls, sure, strict background checks for the provider staff.
Extreme physical security at the data center, data encryption, all that good stuff.
But the book really emphasizes this. The residual risk of losing physical access.
Right.
It always remains.
You can reduce it, but you can't completely eliminate it.
Precisely. That vulnerability is core.
Now, thinking about that residual risk, it brings up a kind of counterintuitive point, doesn't it? In most organizations, IT isn't really a profit center.
Right, it's usually a cost center.
And security, well, security, almost by definition, it hinders business efficiency sometimes.
Oh, definitely. The more secure you make something, often the less efficient it becomes.
Yeah.
There's that friction.
So how does that constant balancing act play out, especially when you're making critical cloud security decisions?
Yeah, that raises the big question, what's actually driving these decisions? And the key takeaway, the really important point, is that business needs drive security, not the other way around. Senior management, they're constantly weighing the potential financial benefits, the ROI of moving to the cloud, against those inherent security risks we just talked about.
It's a cost-benefit analysis, essentially.
Exactly. A calculated risk that steers the choices they make.
So to navigate this, we really need a common language. We need to define the core cloud models, because these distinctions are absolutely fundamental.
Yeah, understanding IaaS, PaaS, SaaS, it's critical for knowing your security posture.
Let's break those down. Starting with the service models. Infrastructure as a service, platform as a service, software as a service. The key thing for your security isn't just the definition.
It's how your responsibility shifts dramatically.
Right. Think of it like a spectrum. With IaaS, infrastructure as a service, you still keep a lot of control.
You're managing the operating system, your applications, your data,
Yeah.
The provider. They handle the underlying physical security, the hardware.
Then you move to PaaS, platform as a service. Your responsibility shrinks a bit.
Yep. You manage your applications and data, but the provider takes care of the infrastructure and the platform, like the OS, the middleware.
And finally, SaaS, software as a service. This is probably the most hands-off for you, the customer.
Totally. Here, you are only responsible for your data. That's it.
Everything else, the application itself, the platform, the infrastructure, the physical security, that's all managed by the provider.
And that directly impacts your security tasks, right?
Yeah.
Patching, access controls. It all depends on where those lines are drawn.
So it's vital to see these models as more than just definitions. They're really guides for negotiating contracts.
Absolutely. They highlight this concept of shared responsibility. Because even with SaaS, some things almost always stay with you. Things like security governance, risk and compliance, GRC data security strategy, application-level security controls, those typically remain the customer's job.
Okay, so that clarifies how services are delivered. But where do they live? The deployment model.
Right. Public cloud is what most people think of first. Owned by a vendor, sold to anyone. And crucially,
It's a multi-tenant environment.
yes, imagine your data sitting on the exact same physical server as your main competitor's data.
And you'd have no way of knowing.
None. That's the public cloud reality. Now, contrast that with a private cloud.
That's different. Dedicated environment.
Exactly. A distributed computing setup, but just for one customer. It could be hosted by the organization itself or by a provider, but it's exclusively yours.
And tying all this together are the contracts. And within those contracts, the service level agreement, the SLA.
Super important, and it's not just a vague promise.
No, it sets specific, quantified goals for services. Response times, uptime percentages.
It's how performance gets measured. It's your key to holding the provider accountable.
That idea of shared responsibility is key, but it leads to a really thorny question. When data gets compromised in the cloud, who's actually on the hook legally?
Yeah. This is where it gets legally very complicated, and it's a point Ben Malisow really emphasizes in the source material. Data owners remain legally responsible for all data they own, period. Even if that data is compromised by a processor, like a cloud provider, maybe even several steps removed.
Wow, even several steps removed.
Yes. The book gives this great kind of stark example. Imagine a cloud provider, let's call them Ostrich Corporation.
Okay.
They have two customers, Acme Inc. and Bravo LLC, competitors. An Ostrich admin, someone working for the provider, sells Acme's sensitive data to Bravo.
Okay, clearly the provider's fault or their employees' fault.
You'd think, but under privacy laws, Acme, the data owner, would still be legally responsible for that breach, even though they did absolutely nothing wrong.
So the initial liability falls on them, even if they can sue Ostrich later.
Exactly. They might recover damages down the road, but that initial legal responsibility, it's theirs. That's huge.
That really is huge.
Yeah.
Okay, so knowing who legally owns the data is one thing. How do we practically manage it day to day in the cloud?
Well, the source stresses data classification and labeling. That's fundamental, and it's the data owner's job.
Like the military system. Unclassified, confidential, secret, top secret.
Exactly like that. It's based on the negative impact if that data gets out. Unauthorized disclosure.
And the labels themselves, they're not just like tags. They carry real weight.
They absolutely do. They need to convey critical info quickly. Who owns it, which office or role, creation date, maybe destruction date, confidentiality level, handling rules. Who can access it?
The source uses that example of U.S. military hard copy data-specific cover sheet colors, bold titles like secret. You know instantly how sensitive it is.
Right. It's about immediate context and reminding the user of the security requirements. Very visual.
What about stuff beyond customer data, like creative works, inventions, intellectual property, IP? How does that fit into the cloud picture?
Another complex area, copyright, patents, trade secrets. Protecting these in the cloud brings unique challenges. It's not just legal definitions anymore.
How so?
Well, take copyright. It protects the tangible expression, right? Not the idea itself. Lasts usually 70 years after the author's death or 120 for work for hire. But think about enforcing that when your tangible expression is a file on a shared server somewhere, maybe in another country. Much easier to copy or misuse if controls aren't tight.
Right, I see. And patents?
They protect ideas, processes, usually 20 years from application. WIPO helps get global recognition across, 152 nations? But again, is the cloud provider's environment secure enough to prevent your patented process from being observed or copied?
And trade secrets, things like formulas, client lists.
Those are protected just by being kept secret, no formal registration. So their protection relies heavily on your internal controls and, crucially, your trust in the cloud provider's security and their staff.
You also mentioned the DMCA, the Digital Millennium Copyright Act, those infamous takedown notices.
Yeah, they allow copyright holders to demand removal of content they suspect infringes their rights. It often puts a burden of proof on the person who posted the content, not the accuser. A powerful tool, especially online.
So for another layer of control beyond just basic logins, there's IRM, Information Rights Management.
Exactly. It's an extra access control layer, often right down at the file level, goes beyond just who can log into the system.
And what makes IRM effective?
Well, the really fascinating part, the key capabilities, according to the source, are continuous monitoring, seeing how the content is actually used.
Okay.
Actively restricting unauthorized replication. That means stopping screen scraping, printing, even simple electronic duplication if it's not allowed.
And the big one.
The ability for the owner to remotely revoke rights at any time someone leaves the company, access denied instantly, even if they have the file, that's powerful.
Given this whole landscape, shared responsibility, remote access, legal liability, what's a major business pitfall to watch out for when picking a cloud provider?
Oh, you've hit on a huge one. Vendor lock-in. It's a classic problem.
Explain that a bit more.
When you hand over control, you build up this dependency. Moving your data, your applications out of that provider's environment can become technically complex and, well, cripplingly expensive.
So you're kind of stuck.
Exactly. You become a potential hostage if you want to leave before your contract is up, or even after if the migration costs are too high.
And there's also vendor lockout.
Right. Equally worrying. That's when the provider just goes out of business, ceases operations. What happens to your data then?
So how do you even begin to avoid that? Seems like a big risk.
It is. And the answer is upfront planning. You must negotiate favorable contract terms for portability right at the beginning. Think about your exit strategy before you even sign on.
Okay, so lock-in and lockout are major strategic risks. What about more insidious cloud-specific vulnerabilities?
Good question. One the source highlights is information bleed.
Information bleed.
Yeah, because you're sharing infrastructure in multi-tenant environments, it's possible, though hopefully rare, for data belonging to one customer to be inadvertently read by another.
Oh, wow.
Or even more subtly, maybe detecting telltale information, like seeing patterns in processing times that give clues about a competitor's activity levels.
Sneaky. What else?
Escalation of privilege. This is a classic security risk, but it has unique dimensions in the cloud.
How so?
An authorized user, maybe even someone from another customer organization sharing the same hardware, might find a way to gain permissions they shouldn't have.
And potentially access your data? Or even control the underlying system?
Potentially, yes. Gaining control of the devices processing your data, or even the hypervisor managing the virtual machines. It's a serious concern.
You know, the infamous Sony PlayStation Network attack back in 2011 comes to mind. 77 million users' info exposed.
Right, and while PSN wasn't strictly cloud in the way we define ISPASS today, it's a powerful example of the scale of compromise possible in these highly connected systems.
And the cost was huge, over $171 million for Sony.
Exactly. It illustrates the massive impact external attackers can have. And it highlights the need to defend against things like denial of service attacks, which are also major threats in the cloud. Securing against these large-scale threats is incredibly relevant, maybe even more complex in the cloud's distributed nature.
So, facing these sophisticated, sometimes unique cloud threats, how do we defend ourselves? What's the approach?
The foundational concept, the bedrock, is defense in depth, sometimes called layered defense. It means using multiple different security controls to protect the same asset. It's not just about having two fences.
Okay.
It's about having a fence and guard patrols and video surveillance and electronic sensors on the fence to detect tampering.
Yeah.
Each layer provides a different kind of protection.
The goal being to make it too complicated or costly for an attacker.
Precisely. Make breaching the defenses so difficult they hopefully just give up and go elsewhere.
Now, speaking of physical defenses, data centers themselves aren't all created equal, are they? The Uptime Institute tiers help illustrate this.
Absolutely. There's a whole spectrum. Imagine a tier 1 data center. It's pretty basic, sensitive to disruptions. Might be okay for, say, cheap backups where occasional downtime isn't catastrophic.
Okay, the low end. What's the high end?
That would be tier 4. The definition is fault-tolerant site infrastructure. This is the premium option.
What makes it fault-tolerant?
Integral redundancy for every single element and system. Power, cooling, network links. Everything has backups, often multiple backups, built right in.
So it's designed to survive almost anything. Planned maintenance, unplanned outages, component failures.
Exactly. Loss of any single component shouldn't bring it down. It's the most robust, highest availability option you can get. Very expensive, of course.
Makes sense. So you have your robust data center, your defense in depth. You also need plans for when things do go wrong, business continuity, disaster recovery, DCDR.
Essential. But having a plan isn't enough. You have to know it works.
Which means testing regularly. even though it can be disruptive.
Yep. Despite the operational interruption it might cause, testing is critical. The source outlines 3 main types.
Okay, what are they?
First, there's tabletop testing, lowest impact. Basically, people sit around a table and talk through their roles and actions in a specific disaster scenario.
Just a discussion.
Right. Then you have the dry run, mid-level impact. Personnel actually perform their assigned tasks, go through the motions, but without affecting the live systems, practicing the procedures.
Okay, more hands-on.
And finally, the full test, highest impact. This involves actual failover, using real data, real backup systems. You're truly simulating the disaster and seeing if the plan holds up under pressure.
That sounds intense but necessary.
Very. And speaking of preparedness, the source mentions having a solid BCDR kit. Secure, durable, compact.
And duplicates.
Yeah.
Tangible and virtual versions stored separately.
Exactly. Because, as the author puts it, and I love this quote, I am paranoid by habit, nature, and trade.
Huh. A sentiment I think many in security can definitely relate to. It's just good practice.
Absolutely.
Now, if we zoom out again, connect this to the bigger picture. The cloud doesn't really care about borders, but laws definitely do.
Oh, yeah. That creates huge legal complexity, especially around data privacy and compliance.
What's fascinating, as the source points out, is just how different the approaches are internationally.
Stark differences. Take the European Union. They treat personal privacy protection as a fundamental human right.
Right. Very strong stance.
And they operate on an opt-in basis for sharing personal data. You have to explicitly agree. And their GDPR, the General Data Protection Regulation.
That puts the responsibility squarely on the data controller.
Ultimately responsible, yes, for any unauthorized disclosure of PII, personal identifiable information, even if it was the cloud provider, the data processor who messed up.
Contrast that with the U.S.
Very different. No single overarching federal privacy law. Instead, it's a patchwork of industry-specific laws like HIPAA for health data, GLBA for financial services.
It generally operates on an opt-out model.
Generally, yes. You're often assumed to consent unless you take steps to opt out. It's a profoundly different philosophical approach to privacy.
Wow, okay. So how does that translate into something practical, like e-discovery? Finding electronic evidence for legal cases. How hard is that in the cloud with these differing laws?
It's incredibly challenging. Think about it. Data is decentralized, often commingled in multi-tenant environments, potentially crossing borders with different legal requirements.
Just finding the specific data for one customer without accidentally grabbing another customer's data on the same disk.
That alone is a significant technical and legal hurdle. Then add the jurisdictional complexities. Yeah, it's tough.
So given all these challenges, how do you build trust in a cloud provider? External audits must play a big role.
A huge role, especially the AICPA's SOC report system and organization controls. SOC2 is particularly relevant here.
What does SOC2 cover?
It reviews the provider's controls related to 5 trust principles: security, availability, processing integrity, confidentiality, and privacy.
But there are different types of SOC2 reports, right? That seems important.
Critically important. Listen closely here. A SOC2 Type 1 report only looks at the design of the controls at a single point in time.
Okay, so it says the controls look good on paper.
Basically, yes. It doesn't actually test if they're implemented properly or if they work effectively over time, which is why Ben Malasso calls it not extremely useful for real assurance.
Oh, okay. So what should you look for?
The SOC2 Type 2 report. This one does review how controls are implemented, how they're maintained, and how effectively they function over a period, usually 6 months or a year.
That sounds much better.
Much better. The source calls the Type 2 report extremely useful for actually assessing a provider's security posture. That's the one you want to see.
Good distinction. And a quick note you mentioned from the source: auditors shouldn't recommend solutions.
Right. To maintain impartiality, their job is to assess and report on the controls, not tell the provider how to fix things.
Are there other certifications worth knowing about?
Sure. There's common criteria, that's ISO IEC 15408, but it only verifies that a product meets the security claims the vendor made about it.
It doesn't say if the security features are actually what you need.
Exactly. And there's the Cloud Security Alliance's STAR program, which includes things like the CIIQ, the Consensus Assessments Initiative Questionnaire. It's a self-assessment, which offers some transparency, but it's still self-reported by the provider.
Okay, got it. So as we start to wrap up this deep dive, let's maybe recap the core insights.
Sounds good. I mean, we've really seen the unique risks that come with losing that direct physical control over data in the cloud.
Absolutely. And The critical importance of understanding that shared responsibility model, knowing exactly what you're responsible for versus the provider.
And the huge impact of different legal and compliance rules across borders, that's a minefield.
Yeah, and we saw how even seemingly small details, like how you label your data or which type of audit report you look at, can have major real-world consequences for security, for legal standing.
And this isn't just, technical jargon for IT folks.
No, not at all.
It's about being informed so you can make better decisions, whether you're a business leader thinking about cloud migration,
Or a developer building cloud apps, or honestly, just anyone trying to understand this complex digital world we're all navigating.
This knowledge helps you ask the right questions, helps you mitigate real risks.
So here's a final thought to leave you with. We've established that data owners stay legally responsible for their data, no matter where it lives. And cloud means it could be almost anywhere.
Right. That fundamental point about liability.
So considering that, what's one single proactive step you will take this week to better understand your own data's journey, its risks, in the cloud? Think about that principle the author mentioned. Ambiguity is scary.
Yeah, where's one area of ambiguity around your cloud data that you could try to clarify for yourself? Could make a real difference.